Hello students, good morning. I am Dr. Vijay Bhandari. So let's start with database design concepts, right? So firstly, I will cover definition of normalizations, then levels of normalizations, first normalization form, and first normal form decompositions. Okay. After that, I will cover functional dependencies, and I will take also some examples of functional dependencies. And after that, I will conclude the lecture. Right. So let's start with the definition of normalizations. So normalization is the process of minimizing redundancies from relations or a set of relations. So redundancy in the terms of we can define it is an relations may cause insertion, deletions, updations, anomalies. so, so it helps to minimize the redundancy in the relations. So normal forms are used to eliminate or reduce redundancy in the database tables, right? So this is the process of which allows you to reduce redundant data within your database, right? The question arises how we will reduce the data or repetitions of data. So it involves restructuring the tables to successfully meeting higher form of normalizations. A properly normalized database should have the following characteristics like first is scalar value in each fields, absence of redundancies, minimal use of null values, and minimal loss of informations, right? So in first normal form, we will see if a relation contains composites or multi-valued attributes, it violates first normal form, or a relation is in first normal form if it does not contain any composite or multi-valued attributes, right? So the relation is in the first normal form if every attributes in that relation is single value attributes, right? We can take an example like student in table, and there will be a multi-valued attributes if so student phone number, and it's decomposed into first normal form, right? So we will see in the next slide, right? And here we will see the levels of normalization also. So levels of normalizations based on the amount of redundancy in the database. So before we skipping the examples, we will cover the levels of normalization. So various levels of normalizations like first normal form, you can see here, and second normal form, third normal form, bias called normal form, that is in short BCNF, and fourth normal form, and fifth normal form, after that domain key normal form. So here I will note you something. Most database should be a third NF or BCNF in order to avoid the database anomalies, right? So we will cover the first normal form in this chapter. Okay, so here we can see also in the diagrammatically we can see here. So take MNF, 5NF, 4NF, third NF, 2NF, 1NF. So each higher level is a subset of lower level, right? Now in the first normal form, a table is considered like book. The name of the table is book, and it will be in a first normal form if all the fields contain only scalar values, right? So example we can take, example we can see here, it is not in first normal form because of multi-valued attributes. Okay, so as we see in last slide, right? So title, author name, author phone, publisher name, publisher phone, price, SBN. So there will be a author phone, multi-values, okay, and there will be also Jones and Smith having a multi-valued phone numbers, right? So and there will be a different multi-values, okay, right? So here also author and author phone numbers columns are not a scalar, that's why it is not in first normal form, so it should be a scalar. Okay, now we will see first normal form decompositions. Okay, so we will see here the place all the items that appears in the repeating group in a new table, designate a primary key for each new table produced, duplicate in the new table the primary key of the table form which the repeating group was extracted, or vice versa, right? So example we can see here in first normal form, we have decomposed the multi-valued attributes. So here the first normal form, it was not in a first normal form, but in this slide we are decomposing the attributes. So here we are taking ISBN, title, publisher name, publisher phone, price, and the next table is ISBN, author name, and author phone. So these are the tables, and we are inserting the values. So balloon having a small house 714 having price $34. So each, you can see here in this in these each particular columns having different unique names and cities values, right? So duplicate in that new table the primary key of the table from which the repeating group was extracted or vice versa, right? Now we'll see here the functional dependencies. What is the functional dependencies? I will explain you here. Okay, so if one set of attributes in a table determines another set of attributes in the table, then the second set of attributes is said to be functionally dependent on the first set of attributes. So we are taking an example, ISBN, title, price. These are the tables and having a multi-valued valued. So there is a table scheme. They are having ISBN, title, price, and functional dependencies. ISBN determines title, ISBN determines price. So here we can say title is fully dependent on ISBN, price is dependent on ISBN. Okay, so right hand side we called it dependent, and left hand side tuples is called that determinant. So determinant determines dependent, right? Now example 2, we are taking the table scheme, publisher ID, publisher name, publisher phone. Functional dependence we can see publisher ID determines publisher phone, publisher ID determines publisher name, comma, publisher phone determines publisher ID. So publisher ID is fully dependent on publisher name, publisher phone, and publisher name is fully dependent on publisher ID, publisher phone fully dependent on publisher ID. And we can take another example, like example 3. We are taking a table scheme like author ID, author name, author phone. Okay, so there will be a functional dependencies like author ID determines author phone. So author phone is fully dependent on author ID. Author ID determines author name. So author name is fully dependent on author ID, and author name and author phone determines author ID. So author ID is fully dependent on author name and author phone. So uh, you are able to understand all the things which I have explained here. So I hope so. If any doubt, so please ask me, right? Now we can take another example like database to track reviews of papers submitted to an academically conference. Prospective authors submitted papers for the review, and possible acceptance in the published conference proceedings details of the entities, right? So author information includes a unique author number, a name, a mailing address, and yeah, unique optional email address, right? So paper information includes the primary author and the paper number, the title, the abstract, and the reviewer status, pending, accepted, rejected. Third is reviewer information includes a reviewer number and the name, the mailing address, and the unique optional email address, right? So completed review includes the reviewer number and the date, the paper number, comments to the authors, comment to the program chairperson, and the ratings. So overall, originality, correctness, style, clarity. Okay, so there will be a functional dependence. We can take an example like schemes, database schemes. Author number determines author name, author email, author address. Author email determines author number. Paper number determines primary author number, title, abstract, status. Okay, reverse number, your name, reverse email, reverse address. Okay, reverse email, reverse number. So we are taking a different ratings are dependent on reverse number and paper number, right? So here we can see the functional dependencies, right? So I hope so you must be understand that these dependencies, functional dependencies in DBMS, right? So uh, thank you. If any doubts, so please ask me. Thank you.